Hello and welcome back to part 3 of the Fundamental Properties of Algebra video. This is video 3 in the series of videos for 1033 Intermediate Algebra. So last time we talked about properties of equality. We're going to continue our discussion of the properties of operations by talking about inverses. So an inverse of an operation is something that undoes that operation. And the way that we're going to look at that is in the context of the inverse of a number under an operation. So this will all make sense in a moment, but you could think of them like opposites. Inverses are opposites of the operations themselves. So as you probably know, the opposite of addition is subtraction. The opposite of multiplication is division, because in some sense they undo each other. But we're going to talk more about this from a higher perspective. We want to talk about the inverses of individual numbers under the operations, and we're going to see how that could actually be used to define subtraction and division. So each number has a unique number that will give you the identity number. We talked about identities last time, right? We talked about how the identity of addition is 0, because when you add 0 to something, it doesn't change. And likewise, the identity of multiplication is 1, because if you multiply something by 1, it doesn't change. So now we want to know, how do I get those numbers back as my output when I do the operation to a number? And this is where we're going to produce the notion of negatives, which are going to be the thing we add to something to get 0, and the notion of fractions and division, reciprocals, the things that I multiply by something to get 1. So for example, we know that if I take 2, if I want to add something to that and get 0, well, there's no positive number that's going to do it. So we concoct these things called the negative numbers, the thing to which I would add 2, and then it would give me 0. Now, this is actually how we think about subtraction in higher mathematics. I think about it in terms of adding a negative number to something to get back to 0. But, really, what does that mean? Well, for positive numbers, you really can think of it in terms of subtraction, right? 2 plus negative 2 is exactly what you'd think of 2 minus positive 2, right? So, and 2 minus 2 is 0. But it's the getting back to 0 thing which is really fundamental here. In the same way, 1/2, or the reciprocal of 2, is the thing that I would multiply by 2 to get 1. And yes, timesing by 1/2 is the same thing as dividing by 2, and 2 divided by 2 is indeed 1, the multiplicative identity. So I bet this kind of seems a little backwards, doesn't it? Here I'm, sort of telling you this is how I want to define subtraction and division. But why don't we just take the usual definitions? What's so wrong with minusing and dividing? This seems more confusing. But actually, it's not more confusing. It's a different way of looking at stuff. And in mathematics, that's usually the main focus. Can we look at this from a different perspective where things might get simpler in a certain sense? And simply put, minusing and dividing are worse than adding and multiplying. They are not as simple as those two operations. One of the ways that you can see that is they're not commutative, right? You can't switch around subtraction and have it be the same. Their division can be switched around, and it is not the same. 3/2 is not 2/3. They're not associative. You can't do it in whatever order you want. If you associate the second 2 versus the first 2, you'll wind up with a different answer. So what gives? I mean, they're more badly behaved. They don't respect the properties that addition and multiplication gave us so obviously. And to be perfectly honest, that means that some expressions won't make sense. You can't just list a bunch of divisions, for example, without any parentheses, and have that make sense. You'll get different things depending on how you evaluate it. But what we have now is a way of writing division and subtraction as addition and multiplication. These always make sense. So from this perspective, if we can rephrase subtraction and rephrase division as addition and multiplication respectively, then those expressions will always make sense, and that's preferable. Now, there are going to be some rules to keep in mind when using these kind of inverses and inverse operations. These are critical notes. I want you to copy the following chart. First of all, there are the sign rules for addition. If you're adding a number plus a negative, that is subtraction. And if that's an easier way for you to think about a certain expression, then by all means do it. But I want you to notice that in the first part, in the left-hand side, a plus minus b, a plus negative b, that's the same as negative b plus a. And we get commutativity because we're using an addition sign there. On the other hand, if you were to have put the negative one first, you could use commutativity of addition to put the negative one second and rewrite it as subtraction. Another way, another thing that we can do to sort of use these new sign properties is by reversing the order of subtraction. If I want to take the difference between two numbers, and that doesn't make sense because maybe we're doing like bigger minus small, or smaller minus bigger, and we're like, well, what does that mean? Well, just flip them around and then take the negative. If you reverse the order of subtraction, you pull out a negative sign. Here's another chart to understand. Here are the sign rules for multiplication. A negative times a negative is a positive, and a negative times a positive is a negative. Now, what I've written is actually true for any value of a and b, but this is a really important thing to remember. If I have two negatives multiplied, the negative sign goes away. And likewise, if I take the negative of a negative, what number do I add to negative a to get 0? Well, it's just positive a again. And you can prove these using some of the previous properties of multiplication. But I will omit that here because we're not going to base this class on proofs. This is more of an operational type class than a proof-based class. But you can derive these sort of sign rules. We're not assuming them. We're not just saying, oh yeah, this is true. You can show that these must happen based on our previous rules, which is an important feature in mathematics. To show that rules that we are using are based on previous rules and not just invented out of nowhere. So here's some basic examples. I want you to also copy these. These are going to be something you can use to try to figure out the praxis exercises, which will be trickier. Here I have 10 plus negative 6. That is the same as 10 minus 6, which is 4. If I were to reverse it and say, what is 6 minus 10? Or what is 6 plus negative 10? Well, that's the same as negative 10 minus 6. And you know 10 minus 6 is 4. So this is negative 4. In general, if you switch the order of subtraction, you pull out a negative sign. Now, if I have two negatives multiplied, that's a positive. If I have a positive times a negative, that's a negative. And if you take the negative of a negative, you just get the positive again. Double negatives cancel. Let's do the praxis exercises. Pause the video at this point and copy these down. I want you to try them. You can figure these out based on the pieces of information that we've been given in the video. The last 3 videos, actually, right? You might need the distributive property. You might need commutativity. You might need all sorts of things. But you have all the tools necessary to solve these problems. So pause the video and give these a try. All right, let's see how you did. So first, let's look at problem 1. And by the way, there are many ways of addressing these praxis exercises. You might not have work that looks exactly like mine, and that's totally fine. We need to arrive at the same answer, but the routes that we take to get there can be all sorts of varied. Let's look at one way to think about it, though. If I want to think about what is 4 plus minus 3 minus 7. Okay, well, first let's take out this 4 minus 3 part. That's just 1, and I know what it is. Now, what about 1 minus 7? Maybe you know that's minus 6, maybe you forgot. But if you switch the order of subtraction, pull out the negative sign, I bet you know what 7 minus 1 is. Now, 7 minus 1 is 6, and so 1 minus 7 is negative 6. What is negative 6 divided by 2? Well, or times a half, whichever one you really like. It's going to be negative because we have a negative and a positive here. And 6 divided by 2 is 3, so this is negative 3. Here's number 2. If I have 6 minus 20 times negative 2, remember our order of operations. We need to do the times part first. So we times 20 by negative 2, and this is indeed 40. Now we're subtracting it, which is the same as adding a negative, or looking at this as a double negation, we get positive 40. Another way of thinking about this is to start from the beginning with plus negative 20, and a negative times a negative is a positive. Either way that you got there, the answer is 56. Problem 3, if I do 3 times the quantity 4 minus 10, well, 4 minus 10 is negative 6, and 3 times negative 6 is minus 18. If I do 4 times 6 times negative 2 plus 10, 6 times negative 2, we do the times part first. We look inside of this parentheses, and we do what's inside here first. That's going to be negative 12 plus 10, which is negative 2. And 4 times negative 2 is negative 8. I want you to notice that we only have sign rules for multiplying. If we add two things together, we either get a sum or a difference, but the sign will depend on who was larger. In this case, negative 12. 12 is larger than 10. And so we're going to wind up overall negative when we add those things together. Finally, let's look at 5. So 5 says we have minus 4 times the quantity, 3 plus 2 times minus 5. We do the 2 times minus 5 first. 3 plus negative 10 is minus 7. Minus 4 times minus 7 is positive 28. So that is the conclusion of the Fundamental Properties of Algebra series of videos, parts 1 to 3. Please copy down the praxis exercises and all of the critical notes and examples and turn those into me at the next class. Thank you for your patience. Have a great day and good luck with your studies.